If you've ever watched Shango's channel, you will hear him refer to his BT modulator, which is what he uses to put a video and audio signal onto a TV channel for use with old televisions. And these were a professional quality modulator used by cable head ends for the most part. I have one here, actually I have a couple. I have one here, it's got a problem. And this is not just any BT modulator. This one has the optional BTS or broadcast stereo television option.
Television is humming because it doesn't know the words ha 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 ha. No, that's not why my television's humming. My television is humming because the signal getting input to it is bad. Really bad. This is a repair video on something I've never opened. Well, I may have opened it before to show the inside of it, but I've never repaired it. And let me explain. Let me kill that noise first. We have a serious case of hum bars here, and well, you can see them in the video, the hum bars, and yeah, it's humming in the audio. This is a piece of equipment that is part of my equipment rack. When people wonder how I have a bunch of analog channels feeding throughout the house, or I can have things like media players and DVD players and cable boxes and stuff that will feed out for distribution around the house. Well, the piece of equipment that's acting up is one such piece of equipment. And this one just happens to be my Channel 12 MTS stereo modulator, which has a Raspberry Pi playing into it, which has got a big hard drive that's loaded up with a whole bunch of rock concerts and jazz concerts and other performances that I just like to watch for ambient. And it's just on random playback. It runs 24 hours a day, 7 days a week. And it just, if I want to watch something, if I want to watch a show that's recorded, most of these shows aren't even in HD. So it doesn't matter because I got a lot of stuff that goes back to the 60s and 70s that was done before there was HD. So the HD stuff that I've got recently, it looks just fine in standard definition. But the important thing was that it had stereo sound because a lot of stuff was recorded in stereo. So I found this modulator, and I haven't shown it to you guys yet because I'm keeping you in suspense. But suspense no more. This is the Blonder Tongue CAMS60 Channelized Agile Modulator. This one is set for Channel 12, and this one was actually used by Shaw Cable back in the days when they had analog channels. This was used to modulate Channel 12 on the Shaw Cable system in Vancouver. I know that because I bought it from RP Electronics, and they got it from Shaw Cable when they took it out of service. This one has the optional BTSC stereo generator in it. It has a minus 20 dB RF test point, RF level control. Yes, this thing can crank out one hell of a strong signal. It would basically drive into the cable system where it would hit amplifiers and go out through the cable system. But there's no reason that you couldn't hook this thing up to a high power amplifier and actually broadcast on the air. Because this thing will put out, I think it's something ridiculous like up to plus 60 dB. I think that's what, oh, well, look at the amplifier. There's an amplifier inside here. And you can control the RF output on it so that you can balance it with the cable system. But it's not designed as a television transmitter modulator, although it could very well be used as one. But that's generally not how broadcast stations operated back in the day. Maybe for a low power station, like if you were using this as a relay station for like a translator for a broadcast of a main television station that they shot down into an alley or somewhere to get a clearer signal. Usually they did that on UHF, but this could have been configured as a UHF configuration as well. But something like this could definitely have been used in those situations because it does meet the full FCC spec for broadcast TV. Although normally in a broadcast station, what you had is you had a visual transmitter and then you had the audio transmitter, which was 4.5 megahertz higher than the video carrier, and it was a separate transmitter. It was a separate FM transmitter. Television went through an AM transmitter, and the sound went through an FM transmitter that was 4.5 megahertz above the visual carrier frequency for the channel that it was on. This combines the two of them together. It does have an IF loop out here, so this could be taken out and put into another op converter for modulation or whatever. Or you could feed it an external signal. Even on the back here, if we look on the back, in addition to your audio video, or your video input, which is a coaxial connector, which I have to use an adapter, and it has left and right audio, but it also has a separate 4.5 input, and you can switch it in. You can switch it between the analog audio, which can come in either through unbalanced or balanced on these input terminal strip here, or you can switch it to external 4.5 in. In that case, you would have a separate TV modulator. So, for example, this will do stereo. But for example, if you were carrying not only a stereo signal, but you were carrying a signal that had the SAP, second audio program, like for different languages, you would run the audio through an external 4.5 megahertz modulator, which had the BTS, broadcast television stereo signal, and the second audio program, and even maybe the professional audio channel, because there was another space for another subcarrier, and you would input that separately, and then the video would go in here, and the modulated audio would go in there. But if you were just using it as a standalone stereo modulator, that was the input. And if it wasn't configured for stereo, it would just be a mono input. But this one's configured for MTS stereo. That's why I bought it. I picked this thing up, oh God, I don't know how many years ago. 10 years ago maybe? I forget. It was a long time ago. I just happened to walk into RP Electronics, and I was looking through their clearance bin, and I came across this little gem. And they were asking $50 for it. I thought, geez, $50 for an MTS stereo modulator. I remember my other stereo modulator, which I have another one. I have a channel 3 or 4 selectable Radio Shack made in the USA, MTS stereo modulator, that I think I paid $100 for, or damn close to it, when Radio Shack was selling it. And that operates on channel 4, and I actually, if I tune my TV to channel 4, I have some scenery that's playing off of another Raspberry Pi, but I have audio service playing music on the audio channel. So I'm not playing the sound that came off of the original video. I have sound coming off another source, which is just music, and I can use that if I just want to play music and have like aerial photography, including stuff that I've done myself, or scenery that I've done, or stuff I've downloaded off of YouTube, like Lounge V stuff, the scenery stuff. I can put that on the beach videos, for example, and just have music playing off of another music source in stereo. And the sound quality off of TV stereo is not that bad. It's fairly comparable to FM radio in stereo. So it's not bad for background. It's obviously not something you're going to listen to if you're going to want to listen to music, but it certainly does the job for ambient background stuff. And they're both playing on Raspberry Pi, like the one that drives this, and the other one. They're both playing on Raspberry Pi 1, the original Raspberry Pi that sold for like $35 when they were new. They're great little media players. They never seem to stop. So I'm just going to get all the screws out of this thing, and then we'll troubleshoot it. It's obviously a problem in the power supply. It's humming. So it's going to be a bad cap. We get this thing working again so I can put it back in service. And it was a pain in the ass to get out. You see the mounting tabs here. Well, these are actually holding a couple more modulators, which are almost as big as this, but they're not stereo, for things like my security cameras and so forth. They're running on stereo, or not stereo, but mono agile modulators too. I have a stack of these. I've got like 5, and they're all stacked together and screwed down to the wall. And of course, this one had to be the one that was attached right to the bracket on the wall. So I had to remove the other ones so that I could get this one out. It's always going to be the hardest one to get at that breaks. The one that's at the top of the stack, it never breaks. It's always the one that's at the bottom, and everything else is screwed to it. Anyway, let me get this thing apart. All right, all the screws are out. We'll reveal the inside. You guys are going to say, oh, it's empty. It's empty. What's with the big box? Why has it got such a big box? There's nothing in it. Well, There is stuff in it. There definitely is stuff in here. Let's go over as best I can what is what. Because I really don't know what is what. What I do know is that this is the power supply over here, and that is where the problem is going to be. The problem is going to be either a connection's let go or a capacitor has gone bad. Here's the transformer here. It's a billion transformer. Made in China. This unit was made in USA, apparently, but this part's made in China. And let's see what this is. This is the, I believe this one is the filter. This is the filter for, you can set the channel, right? You can set what channel you want to have it on by setting these dipshit switches. This is the filter that keeps the harmonics out of the signal. And this is one of the things that the professional modulators such as this have. The little cheap ones that you can buy. I don't know if you can buy them anymore, but the Channel Master and all those, you could get multi-channel modulators. They were always up in the UHF band. And the problem with them was, well, they didn't have any filtering. They had no filtering whatsoever. Yeah, this is a 60 dB, you see? Plus 60 dB RF out. 60 dB amplifier is what this is. Because your RF in here plus your 12 volts. And RF out plus 60 dB. This might be this one. I think is the filter over here. This is the tunable amplifier, and this is the filter. If I'm not mistaken, I'm not going to open it up, but I believe that's what it is. This is the filter here. It's got the loop through here. This one's coming in, so the RF or the IF is coming out of this. You can see this one. If we follow the coax, this is the IF out. This is the video modulator here. This is the MTS portion. The audio modulator, I believe this one here, this circuit board on top, that one is the MTS, the stereo modulator portion. And it looks like this one had adjustments for left plus right audio and mono adjust, right? And left plus right. Yeah, so this is left plus right balance. This is the modulator here, and this is the stereo add-on, if I'm not mistaken. This board over here, this is the video module. So video, if we follow video from here, and I think the IF probably comes over here as well. Yeah, video and IF. There's the IF audio in, and this is the video in here. So this is the video modulator, and then the output from this goes over to here, goes out through that loop through and comes back, and then from there it goes into this box. This is probably the vestigial sideband filter, and then out from here this comes out and goes into this, which is the RF in plus the power for it, because it's got 12 volts going in on the coax as well. The amplifier comes out, and then this one goes out to the back here. If we follow the cables, this one goes into there. The RF output is there, and this is a 20 dB tap which feeds out, and this comes back and ends up on the front. That is the layout. And the video from this, I'm just looking at the way this thing's set up. The sound from this is modulated on a 4.5 megahertz carrier. The sound, the composite sound, the stereo sound comes from here, and it goes back into the video modulator over here and would be injected where the audio carrier would be if you were using an external source. I think that's how it works. Pretty sure that's how it works. Power comes in from this one over there, and the audio comes in over here. And you got your left and your right audio is here. Your two audio signals there. I think that's it. Ground. These wires go back here to the audio input, which are also connected over here to these other ones. They're just parallel. They're paralleled with these inputs over here, you see, to the terminal strip. The ones on the end don't hook up to anything. Audio comes in, left and right. It's modulated. It's sent out this little cable here. This little cable brings it over to this side, into there. This one's not used because we're not using external fed audio, but if we were using external fed audio, it would be over there, and it would be a switch over here to select one or the other.
And then the audio is added to the video. It's sent out here over to this loop through, which is IF. This would be probably at 45 megahertz because IF output. And then from there it goes into this. This is going to put up the put the frequency up to whatever it's set to, channel 12 in this case. And then again, this is the amplifier, and all the dip shit switches in here, they are used to change the filtering in the amplifier, because the filtering would be inside this, if I'm not mistaken. Anyway, that's beside the point. We have a problem with the sound. So there's a 12 volt regulator over here as well. I think this whole block probably lifts out of this thing. If we look on the side, it tells you what the information is on here. Channel 12. Anyway, I'm just going to tap this thing because it was coming and going, the noise, so it might be a bad connection. So let me just switch back to I got the camera on my monitor now, so let me just switch back to the color bars and turn the sound on. See whether it's a connection, because it might be a connection on here. Oh. We may have a connection problem. I'll show you the screen when I'm doing this. When I tapped on that it might be the regulator. It could very well be that regulator's bad. See? Anyway, I think I gotta pull this board out. See when I tap it? It could be a connection. Could be the caps too, but it could very well just be that it's a connection. Anyway, let's pull the board. What you'll notice on here, you've got your AC input from the transformer. This has got two power supplies in it, looks like. It's got a 30 volt supply. That's obviously going to be for like the amplifier here. And it's got a 12 volt supply. And the 12 volt supply, it probably powers everything else up. And these are 12 volt lines over here. This is the 30 volt line. I doubt it's a connection on these. I mean, it even could be a connection problem, you know, but see how this thing lifts out. Looks like two short ones and one long one. Well, like they've been Loctited in. They've never been removed. I don't know how old this thing is. The label for the date code is 0250. By that time, these were going out. I can't see it. 0233. Maybe it is 2002. I wouldn't have thought that they would have made something in 2002 for analog TV, because high definition TV was already a thing. Oh, this is a Torx. It just didn't look that way. HD TV was already around. I thought maybe this was a lot earlier than that, but you know, looking at the date code on here, 0233, it could be like the 33rd week of 2002. Okay, well, maybe it is. Maybe it is more recent vintage than I thought. But oh, another one down here. Anyway, it's pretty old. I've had it for a while. I've had this thing at least 10 years. Oh, more than that, I think. More than 10 years. I've had it probably since 2010. I'd have to see if I can remember when I bought it. What else is holding this in place? There's something else. There's something else holding this heatsink in place. Oh, they're not. They're just heatsink compound. That's all it was. Okay, lift the board out. And get a look at the bottom of it here. It could be the regulator too that's going bad, right? It's not all that tight on there. What is this, a 12 volt? I think this is a 12 volt regulator. I might just change this if I've got one. I don't know if I've got one 12 volter, but for sure we're gonna change the caps on this one because I've got it out. And 1000 microfarad at 35. But that's loose. That's really loose, that heatsink. That screw is loose. That nut, which is actually part of that. These were studs for other regulators, right? The nut that holds this on is well, it's not even finger tight.
So that might be part of the problem. It might be the regulator is shot and the regulator is overheated. I mean, there was paste on there, but it certainly wasn't very tight. Now I got heat sink goop all over my fingers. Made in China. So it says. I always thought this thing was made in the States. Made in USA. It says made in USA on the back here. And yet, this says made in China. So, there you go. And that says made in China. The transformer says made in China. What else is made in China? Everything's made in China. And they just put it in the box in the States. That's probably more accurate. If made in USA means anything like made in Canada, it just means 51% was made domestically. For our stuff, it has to say product of Canada or produced in Canada to be like 98%. So I'm going to pull these caps so I can test them on the ESR meter and see how bad they are. The 1000 at 35. We'll see if they're bad. They don't look bad. There's no leakage or anything. We'll just make sure that they are discharged completely. Are my boards labeled which way they go in? Yeah, they're positive. Yeah, they're labeled. Okay. So I make sure that the boards have the plus on them. All right, got the ESR meter out here, and we'll just check this one and see how it looks. It looks to be okay. It doesn't look to be leaking or anything, so we'll check it. Thousand microfarad at 35 volts should be no worse than 0.07 ohms. Yeah, it's bad. 18 ohms. That was bad. So if that was bad, I'm sure that the other one probably is also bad. Let's pull it. These might be the two that are bad. See, there's no sign of bulging or anything on them, but there's no sign of leakage, but they're hammered to death from the constant pulses from the power supply. And since this runs 24 hours a day, 7 days a week, here's the other one. It is also probably measuring in the high ohms range. Just make sure that my meter is still zeroed, which it is. Make sure the cap is completely discharged. And this one's measuring 4.5 ohms. So these are both bad. They're 1000 at 35 volts. I got to go and dig up a couple of caps and we'll change those out. And that might fix this thing, actually. All right, I got one here. This one's a pull. But this is what a 1000 microfarad at 35 volts should be more like. 0.1. 1000 at 35 says it should be like, well, 0.0. Well, no, wait a minute. 0.07. And this one's 0.1. So even this one is starting to go. But it's a lot better than the other ones. I do have others here. They're quite a bit bigger, but I certainly could put them in. And since I don't want to have to be doing this again, we'll just see what this one looks like. I think I got some more here too. I don't have the 35 volts though, but this one here is 0.05. It's a brand new one. This one is I think it's a Panasonic cap actually. No, it's not. But that one's a brand new one. Let's see what else I've got here. I know I've got some others here. I got another one here. The other one I've got is a really big one. It's like a 63 volt. This one here is, what is this one? This is a 50. The other one's a 63. It's much taller. But I've got one I pulled out of a power supply here, 1000 at 35 volts, 0.03. So this one's probably okay. This one here is also probably okay, but it's measuring, did I measure it right the first time? It's measuring 0.08. Why the heck? Maybe the first time I measured it, my meter wasn't making a good connection, but this is the one I just checked, which was listed as a good one, and it's measuring 0.08. So it's good as well. So maybe I can just go with those two, because these are the ones that came out of it. And as you can clearly see, well, 24 ohms, yeah, that's bad. And this one here is 6.5. It's bad. Got this brand new one, which is look at the brand of this thing. Futten. It's 105 degree. There's a brand new one, and it's say 0.04. But here are these other ones, 0.08. 0.03. So these ones are probably just fine. Say I do have another one here, a 63. I think it's a 63. I don't know if I've got enough room in the cabinet. That's the thing. This one might be just a little bit too. Well, it might fit in there. It might. It might be just a little bit too tall. This is a 63. And of course, you really don't want to go up in voltage, because the higher the voltage you go, the higher your ESR is, right? But this one's 0.04, so this one's also good. But I would expect it. It's a new one, and it's just another 85 degree. It's not even a high temperature one. So I might be just putting in these two that were pulls, only because they're measuring good, and they're the right voltage and the low profile. So maybe we'll just throw these two in. I think that will be okay. After all, it's mine. So I mean, if it fails 5 years from now, we'll be doing this again. But I think we'll be okay with this one. So I'm going to mount these ones. I know you guys are probably thinking, okay, well, the ESR tested good, but how's the capacity? Well, we can test that too with the capacity tester. It's getting there. It's within spec for sure. The other one. Yeah, we're good. We're within spec. 10% tolerance, right? So it could be as much as 1100 and as low as 900. We're in that 10% range, so we're good. One thing's nice is the unit is easy to work on. Another thing about going up real up in the voltage is because the pin spacing will also be different, right? For the larger, I gotta clean some solder off this. But you go to a larger voltage, like a 50 or a 63, the cap is physically larger and the pin spacing is going to be different. So that's one. And the other one, be careful not to put it in backwards, because we don't need a shocking experience. Speaking of shocking experience, my son got that yesterday when he was driving to work in his car with the wife. And they're driving along and they heard this pop. And then the car started to smell like smoke. And I was wondering what's going on. And, well, it was a very shocking experience, let's just say. A shock blew up. But, you know, the car's 20 years old, and it's probably the original shocks on it. And it took out the tire. When the shock broke, the wheel kind of twisted a bit, or the spring moved, and was rubbing up against the inside of the tire. And of course, then the smell of burning rubber, and the car was disabled. So it's like that's what you call a shocking experience. Okay, those are in. I should probably check a couple of these other ones as well. The 220 here. I think these little ones are probably okay, but I'll check this 220. We'll pop it out and check it and see how it is looking, just because I'm in here. And if it's anything questionable, it will be swapped out while I'm here. Another good old Chinese cap. This is a 220 at 35 volts, so 220 at 35 volts should be like 0.17 would be what we would expect a new one to be in the range of, and this one is open. So this one's also bad. This one might have been the one that was causing it. The other ones were going bad. This one's completely open. So, and again, no indication, nothing leaking, nothing bulging. You see, look,
It looked perfect, but the ESR meter doesn't lie. 220 at 35 volts. Let's dig one of those up. This is a 220 at 63. It will have to do. Now to make the perfectionist cringe. Klein. Buy it once, own it for life. That one is measuring, what was that, 12 ohms? This one's measuring 12 ohms. Make sure to zero out the meter first. 13 ohms, and this one is a 47 at 63. So, yeah, that should be like 0.56. So let me find a 47 at 63. We'll change this one. I'll probably have to change all these caps, you know, because they've all been hammered the same way by half and full wave. Well, these are a full wave rectifier, but still 60 hertz, right? After a number of years, they will dry out. So let me get one of those. Now this is the one that the trace was kind of lifting on, so I'm going to kind of double back on this one and just make sure that it's solid. So there's the positive leg, and I'll just take this one here and I'll bend it over here and I'll solder it down over here. I'm going to check a few of these other small ones in here as well. See how bad this one is. I bet it's bad too. Yep. It's bad too. Or is it bad 3? Or is it bad 5? It's bad. It's bad. This is a this one is a 10 at 50 volts. Okay, replace that one. Let's just check some of the others. I'm checking them in circuit because the ESR meter is mostly accurate in circuit. It'll at least tell me if they're way off. We'll know. 13. That was probably, what is that? What size is that one? That one is a what is it? It's a 10 at 50. 10 at 50 is should be like between 2.4 and 3.3, and this one was yeah, that one's off, so we'll change that one. And there's only a few more in here. We'll check these ones here. This one here is also looks like that one's also open. Yeah, it's bad. Okay, I must change the others. I'll do them off camera. One of these I pulled out was measured open, but it's actually not going anywhere, so I'm not going to have to change it. And that was a 10 microfarad here that was measuring open, but it actually is not connected to anything. If we follow the trace, it goes over to this one, which was a 5 volt supply, which is not used on this one. So one side goes to here, and we follow it around. It goes and jumpers over to here and over to here, and then ends up over here on this 5 volt regulator, which is non-existent. So some of these caps aren't even hooked up to anything, so I don't need to worry about C2, because C2 is not doing anything. This one is, but this one's not doing anything. So we don't need to worry about that one. See, there's maybe some others that were populated and not even connected to anything, because the traces go nowhere. So it was a cap that was just sitting there doing nothing. You wonder why that got put into the board. Oh, I know the reason why. It was made in China, and someone stuck it on the board, and it wasn't even needed. And the only reason I noticed that, I looked at it and said, where's the polarity? It's not even marked. And I'm looking at it, well, wait a second. This doesn't go anywhere. It goes over to the 5 volt rail, which on this particular model is not used. This is the last one. It's another 10 microfarad at 50 volt. So all the caps in here that are actually connected to something have now been changed. So we'll reinstall. Oh, I'm going to look at some of the connections on here first before I reinstall it, but reinstall the board and we'll test it out, and it should work. Okay, time to put the screws back in. I think there was a little cover here that I got to put back in as well that covers up the AC. Not that I'm going to get my fingers into it, but there is a cover that goes on there. I think I found the made in USA part. The Torx screws. Isn't that a US invention? They took the superior Canadian invention, the Robertson screw, and just added an extra 4 points to it. There we go. Now we have a better screw. Oh, I know why they put the longer screw in. It holds the barrier in place. That's why. That stops this cover from coming off. That's why the longer screw is here. All right, moment of truth. Let's turn on the power. Oh, look, it's broken. Let everything settle down. Get on frequency. Yeah, I think it looks a little better. Now, don't hear that nasty hum anymore. I'll put some sound through it so you guys can hear how this thing sounds, at least through the TV. Volume. Where's my... Got to turn the volume up, I think, on the media player. It's a little low. There we go.
983.fm, our website. All right, whose side are you on? Matt Bianco is next. Vancouver's coolest vibe, Wave 98.3.
Yeah, it's sounding pretty good. If I tune that, I've just got the radio tuner on, right?
I've seen over the last...
Number one.
Reassembly.
We made more.
It's wonderful. It's stereo. You can hear it. You can hear all the TV speakers. I gotta be careful I don't stay on anything too long here. But yeah, it does sound good.
Right now, we have thousands of loyal listeners.
I'll go and I'll just kill that. Turn that tuner off. For now, I'm going to put this thing back together, and I'll go remount it, and we'll take a listen to it in its intended use, playing something from my media player. Alright, it's back in service. And no more interference. This is not a very good copy. I've actually got this concert on Laserdisc, but I downloaded it. No, I don't have this one. I have the Acropolis. Yanni at the Acropolis. This is Yanni in LA, but this is not a very good quality copy, but it's the only one I've got. So, but the sound isn't too bad. The video sucks, but the sound isn't too bad on it. But anyway, it's back up and running. No more noise bars, no more hum. Catch you in the next one. Bye.